So we've learned how to simplify individual radical expressions. Now let's multiply multiple radical expressions and then simplify. The basis for this rule is what we already learned about the product rule. If I can take a radical defined as a times b, I can break it up into its own individual radicals. Radical a times radical b. I'm just going to reverse that process for multiplying. I'm going to take radical a, multiply it by radical b, and I'll get a product, radical a times b. Then we need to consider simplifying. Sometimes we'll multiply and we'll leave it just as that, but if there's a perfect square factor left under our new product, then I need to keep going. So these three examples are all going to follow that rule. So I'm going to begin by doing root 5 times root 10. My product is just like doing regular 5 times 10, except it's going to have a radical sign. So this becomes square root 50. Let's think if 50 is simplified or not. Any perfect square factors? I know it has a perfect square factor of 25, so let's go root 25, root 2. For a final answer, I know this is 5, so 5 radical 2. Based off of that, I would suggest pausing the video, seeing if you can get these next two. All right, we're ready to resume. Root 6 times root 8, that's going to give me root 48. Definitely have perfect square factors for 48. I know 4, but the best one is 16. So to make this a little bit easier for you, if you go right to root 16 and root 3, only takes one step to get to your final answer of 4 root 3. One more. Product of 21 and 3 is going to be radical 63. Perfect square factor, 9 and 7. So root 9, root 7. Just to reiterate, when you simplify a radical, I only want you to consider perfect square factors. It's going to be a time suck to factor it into anything else. We want to look for perfect square factors only. Two more styles of multiplication. Let's consider some variables now. So we have two expressions. Everything is underneath the radical sign here. I am going to multiply this and get one term that I can then simplify. So let's consider just the numbers here. Root 8 and root 5 is going to give me root 40. There's nothing outside of the radical sign here so far. And then we have root x and root x squared. Based off your exponent rules, that's going to give me x cubed. I have a y squared, no y in the second factor, so let's leave it as y squared. Now I just need to simplify this one term. So we'll break it up into parts. I would say radical 40, radical x cubed, radical y squared. Perfect square factor for 40, that'd be 4 and 10. That's the best we can do. It's going to give me 2 root 10. X cubed, remember with a variable like this, it's an odd exponent, so I'm going to break it into factors of x squared and x. Simplify square root x squared into x. So I have x root x. Root y squared is just going to be a perfect square. The square root of y squared is y. So I have all this. Let's write this in a simplified form. Let's take everything that's, let's take everything that's been simplified. Let's take 2, x, and y. And then combine what's left underneath the radical sign. So it's root 10 and root x. So I'm going to make it root 10x. So it's a little crushed there at the end, but my answer here is 2xy radical 10x. Last thing here, we're going to combine these radical rules with the use of the distributive property. So I have a radical 3, and it's times the expression 2 plus root 12. Let's see what happens when I distribute. Root 3 times 2. Remember, if I have a non-radical, that's always going to be written first. So the first part of distribution here is going to be 2 root 3. Root 3 times root 12. Root 36. Anything else I can do with this? Well, 2 root 3 is done. Root 36 is one of your perfect squares. If you can get a perfect square from one of these expressions, by all means, you definitely need to recognize that. So this is really just 6. And that's complete. Try this one on your own if you'd like. Hit pause and continue. Distribute root 5 to 4. Distribute root 5 to negative root 20, so minus root 100. Root 100, better see it's 10. And that's complete. So pretty thorough examination of multiplication. Next lesson we'll look at division and something called rationalizing.